What is an electrocardiogram or an ECG? Some people call this an EKG, especially the British who spell cardio with a K, right? So that's where EKG came from. So an ECG or an electrocardiogram is a measure of the electrical conductivity through the heart. And so it's just a measure of essentially the electrical current that is moving through the heart. All right. So when you look at it, you'll probably, recognize something that maybe looks like this, right? You'll see this a lot when you look up sort of cardiac physiology, right? You look up EKG, ECG, it's going to look something like this, right? But what creates these waves in your ECG? Okay, well, that's how we're measuring the electrical conductivity through the heart. So let's imagine that we have a person. Now, you're not allowed to laugh at my drawings because I willingly admit I am an awful artist. Okay, but let's take Bob here, and Bob's hands are going to come out this way for sake of my argument. Bob's going to have a little bit of a belly with him, like so. And then we're going to take Bob's feet, and we're going to put them down here. Like so. All right, very simplistic drawing because I don't like to waste time with drawings, okay? Now, if we put an electrode on Bob here, and we put one over here, we can call this a negative electrode, and we can call this a positive electrode. Okay, so we set up a diode, right, with a negative end and a positive end. Okay, and we can measure the electrical conductance across this diode. Okay, now, if the signal, right, the electrical signal current moves towards the positive end, okay, that equals an upward deflection in our readout. If the electrical current moves towards the negative end of our diode, we get a negative deflection in our readout. Now, if it runs perpendicular to that diode, what's going to happen is you get what's called a biphasic readout. You get upward, downward, back to normal. Okay, so biphasic. All right, so that is what we call lead 1. Okay, now we can also take and put one down here on the left leg, and we can run a diode in this direction, where we have the negative end up here, and we have the positive end down here. Okay, and we can do another one where we put the negative end up here, and we run it this way, and we put the positive end down here. Okay, so this gives us lead 1, lead 2, and lead 3. You've probably maybe seen these before. Okay, so notice that it forms this nice little triangle. This is something known as Einthoven's triangle, and it's the basis of an ECG or an EKG. Okay, now notice that Einthoven's triangle, right, just gives us the measure of the electrical signal lateral and then superior and inferior, right? So left and right, up and down, essentially is what it does. Okay, now what we can do is we can take a little bit of physics and we can say, okay, we can make leads that are also perpendicular to our current leads that we have. So what we can do is we can take and we can make one in this direction here, like so, make this positive, make this negative, okay, and this is what we're going to call AVF. Okay, we can take one and we can run it sort of perpendicular to this one here, where we make this positive here and this negative here, and we're going to call that one AVL. And then we can take another one and run it this direction, where we call this the positive end here, the negative end over here, and we're going to call this one AVR. Okay? Now, what we can do is we can understand physics a little bit, and we can say, okay, this is lead 1. This is lead 2. This is lead 3. Okay. Then I can say I have lead AVF, I have lead AVL, and I have lead AVR. Okay. Now I can take this lead 2, right, and I can slide it, because in vector math, right, everybody remember vector math from physics, this vector, right, is the same as this vector, okay, which means that this vector is the same as this vector, right, as long as it has the same magnitude in the same direction. So what I can do is I can sort of move these different vectors, and what I can do is I can say, okay, here's lead 1, here's lead 2, so this is 1, here's 2, here's lead 3, okay, then I can add in my other vectors, right, and I can say, okay, here is AVR, here is AVF, and here is AVL. Okay, and this whole structure here is known as the cardiac axis wheel. And what we can do is we can look at the overall readout from each one of the leads, and we can determine what is the overall direction of the electrical current. Now, this, right, notice that there are 6 leads. This is what we call a 6-lead ECG or EKG. Okay, but notice, right, up here, that it only gives us on the coronal plane, right? Left and right, up and down. That's all it gives us. Same thing with our AVL, AVF, and AVR. Left and right, up and down. Okay, if we want to measure front and back, or anterior, posterior, we have to change this into what we call a 12-lead ECG. But we're not going to do that. We'll leave that for another time. Okay, so if we do that, right, we can know, if we say we look at, okay, what is the readout on AVL. Let's take this one for example, right here, AVL. Okay, if the readout is in a positive direction for AVL, right, I know, like on my AVL, right, that the positive direction is up here, right? Positive direction is up here on the AVL. So the signal is running that direction if I get a positive readout on AVL lead. What happens if I get a negative readout on AVL? Well, now it's running in that direction. Okay, so what we can do, right, is we can look at the EKG or the ECG, and we can look to see how is the signal, the electrical current, running throughout the heart, and that is an awesome diagnostic tool for us understanding the electrical conductivity of the heart, what's going on in the heart, and whether things are operating normally. Because this signal, right, the electrical signal, is just the depolarization and repolarization of the cardiomyocytes, the cells of the heart. So if they are not firing correctly, if they're not depolarizing correctly, let's say they're dead for some odd reason, just certain cells are dead, that will impact the way that the signal runs throughout the heart. So what an awesome diagnostic tool. So in the next videos, we'll talk about how we can look at EKGs and learn different things that are happening inside of the heart.